Everyone, if you don't hear me, just give me some indication that I shall speak louder, right? So, my name is Christoph. I'm from the German Aerospace Center, and despite that name, we are actually doing energy research. And I want to present you our electricity market model, AMIRIS. And AMIRIS stands for the Open Agent-Based Market Model for the Investigation of Renewable and Integrated Energy Systems. So quite long title, but otherwise we wouldn't fit in all of the letters that we had before. So, right, and it's an agent-based market model for the power market, and it models business-oriented decisions for dispatch considering the regulatory framework. And we focus on renewable energy sources and flexibility options. And as I'm here, this model is completely open source. You can find it in our GitLab repository. The key functionalities of this model is that we simulate the trading and operation of power generation plants and flexibility options. We model from a business-oriented perspective. So we model the behavior under uncertainty of the individual agents with an hourly resolution, or even higher if you want to, and spatial resolution of market zones. So, for example, your national energy market, but you can define that at any range that you want to. And inputs to that model are the power plant capacities, efficiencies, and availabilities of these power plants, feed-in potentials for renewables, demand time series, fuel prices, and CO2 prices. You feed that into AMIRIS, and what you get is electricity prices, CO2 emissions, system costs, costs for support instruments, for example, the dispatch of the power plants, and you can derive market values for all of the units in the simulation. Now, example application of this model is the question to model market dynamics. So how will electricity prices evolve in different future scenarios that you can think of, how support instruments impact the behavior of the agents, if there is enough support for renewable energy sources maybe, or even too much, or how do household electricity tariffs impact the flexibility level of these households, especially from heat pumps, electric vehicles, or storage units in that household, for example. So these are example applications that we applied AMIRIS for. We have several other applications as well. Now, as an agent-based model, the central thing of our model are the agents, right? And we have different types of agent in our model. Of course, we consider markets. At markets, we determine prices for goods. For example, at the day-ahead market, we can determine the electricity price. But we have also other markets like the fuels market or the CO2 market, which in our thing are kind of stubbed, which will only feed in the prices that you pre-decided on for the simulation. We have traders that operate on these markets. They fulfill marketing strategies, so they bid for goods or they offer goods. And so we have like supply traders or demand traders. And those will create bids and place them at the electricity market. Then, once the price is awarded and the bids are awarded, they will feed back to the power plant operators, and they will control the power plants and operate them. Flexibility providers allow to model electrolysis units, for example, or storage units, or heat pump units, for example, and they try to minimize their costs or maximize their profit from the operation. And they need forecasts that we have in our model, and these forecasts are provided by dedicated forecasting agents. Also, we have explicit consideration of support policies, and for that we have a support policy agent. Now, you can see how all of these agents interact with each other. We have different kind of connections between those agents. We have flows of money, flows of energy, and also flows of information between these different agents, and these then form the whole simulation. And as a result of these simulations, you can see here backtesting results. All of the data is open source or open access, so you can download these data from our example repository. and run the simulation. As you can see here is electricity time series over the last over a few weeks in the year 2019 for the German country, and you can see we achieved quite a good fit for the historical data in gray, where our model results are blue. Now, how do we actually use it? So AMIRIS is kind of a simulation written in Java using the open framework for distributed agent-based modeling of energy systems, also a long name, and it's also developed by us. That's the course probably. And that's FAME for short in that case. And here we define AMIRIS, which then communicates with the input-output model written in Python, which collects your configuration files as YAML standards, puts all your CSV data in there, makes a binary input file, runs the Java simulation on one or multiple cores. Usually I only use like my laptop. And then you create binary output files, which then are translated into readable CSV files again using FAME.io. This is also completely open source, so feel free to build your own models with that framework as well. And for an easy access, we have a Python wrapper for this, AMIRIS-Py, that makes life way easier. So if you want to use AMIRIS, it's basically creating a Python environment, running pip install AMIRIS-Py. AMIRIS install will download the whole model and all of the example files, and then run the model with an AMIRIS run command and the downloaded model and the files. And after maximum 5 minutes, if you have Java and Python already installed in your system, you will have your first result ready for one of the examples in the simulation here. If you want to connect your own model maybe to our to AMIRIS, it's quite easy. You can we provide a URL model service class within our code that allows easy connection with your model, basically anything. So it's an API web API approach basically, so you can send web requests to your API and interchange data. And if you don't have an API, it's super easy to set one up. So you can couple with virtually any model at runtime of the AMIRIS model to your own one. And we use this a lot if we don't want to code our special code in Java, for example, or we have a different model in Python or something. Then we use this this kind of remote call to the specialized model, and this works quite well. For example, for load shifting optimization or heat pump operation, we have used this, and we are currently using this also for machine learning based predictions of the electricity price forecasts. We develop our model as following the FAIR for research software principles. So we want to have our model findable, accessible, interoperable, and reusable. All of these links are on the downloadable. Can follow all of these links on the downloads from this presentation. And we also have some external users already, which we are quite proud of. And if you want to join our community and want to work with us or work with the model, feel free to do so, download it, use it. If you have any questions or any not happy with our model and complaints, maybe something like that, feel free to post your questions or complaints or suggestions at the Open Mod forum. Send us an email or discuss with us at our open forum that we have every Friday at 10 o'clock Central European time. And of course, feel free to raise issues or contribute in our repositories. Thank you. Are there any questions? Yes?
What are the shining use cases AMIRIS has changed or insights has given?
So in our group, we are doing a lot of research on the integration of renewables and you required support instruments. So we have several research projects where we try to understand which kind of support instruments that there are, so like feed-in tariffs or market premia or stuff like that, work best for the future, and exactly that, yeah. So, yes?
Do you guys work with any sort of spillover events where you say there's a flow of information that gets cut because one of the instruments goes down, and then that transfers a flow of money, which then creates a cut in the electricity, which creates a blackout. Do you study that kind of cascaded events? Because since you have multiple flows, inflation money, or somebody stops paying because they don't have any more money, so then they cut electricity and that stops the flow of power. So what do you study that?
So I try to repeat the question. So you ask if we kind of model complex spillover effects between the different flows that are presented. I'd say no. Yeah. So kind of the system that we presented is kind of static as well. So the flows in there, you can change the flows numbers, but not really kind of create new connections or make a kind of evolving system during the simulation. You would need to do that manually, probably. Right. Thank you.